Okay, so as we start here on Tuesday, October 12th, we're going to be looking at picking up where we left off, and we're going to be starting on Chapter 9 here in our second Creo class, Working Drawings Using Creo. And you'll notice that I have here, Chapter 9, everywhere that we're going to be talking about it. So for the next couple days, we're going to be looking at Chapter 9. Now, next week, Monday, Tuesday, Wednesday, you do not have class. That's our fall break. Okay, you shouldn't have any classes. If you're signed up for any other courses besides this one, you shouldn't have any other courses. Okay, we give you guys a little bit of a break there, but we resume on Thursday, Friday. So if you do have Thursday, Friday classes, which we do here in this class, we will be meeting on Thursday for our normal virtual lecture and kind of buttoning up Chapter 9. Okay. Chapter 9 homework, the tutorials, and you'll kind of get an idea of that. I'm actually going to have this due on Friday, okay, of next week, only because then we can start fresh on the 25th with our next subject. So we're going to kind of take these next couple times to get through those tutorials, make sure we have a good understanding of how putting things together in assembly. You'll get a couple extra days here, a long weekend if you would, but the tutorials will be due at the end of next week on a Friday. That'll be probably your only Friday due date that I'm going to have, but it's just because we have this break right here. It doesn't feel like I want to give you another weekend to keep that going. So we're gonna end it right there, but then we're going to start new on the 25th with our next subject. So if we go to our learning plans, you'll notice that our link for Blue Jeans is up in the top where we normally see it. The recording for today will be listed in the virtual live lecture recordings for this fall 2021 semester, and I'll be doing them by date in there. Then you'll notice that there's a day number 1, getting settled. Now, based on the fact that everybody has taken Creo 1 already and has been doing, well and kind of navigating through, this is just a repeat of that stuff that we want to make sure is in place so that you can successfully navigate the course, whether you're here on campus or you're off campus. So I'm not going to repeat this stuff, and there is no syllabus quiz or anything like that for you to do. There's no discussion that you have to do this time around, but it's just a reminder of, can I get my email both on and off campus? Can I access the network both on and off campus? If I need to, if you notice, and we're going to probably start taxing your computers in this class because now we're going to be pulling multiple drawings in for assemblies. That is usually going to take a lot of RAM and a lot of graphics card speed. If you were using the locally loaded Creo 7 previous to this as a student version, and you were on a computer that was maybe just getting by, you may find that you may need to switch over to maybe one of the other options here, being using Citrix on an LTC computer or coming to campus. We would love to have you here if you haven't been here all that often. The computers are a lot faster, but making sure that you have the software available to you on and off campus or wherever you're going to work, okay, wherever you're going to work. I also have a reminder here of the LTC logins, password formats, for the different things that you need to access. So I think we're getting closer to that one sign-on for everything that you may need, but we're not quite there yet. So this is here for your reference. When you're on campus, there are these orange cards that is that very same information. Okay. So if you've used the orange cards before when you're here, that's exactly what is on there. All right. So that's day 1 stuff, really nothing to do there unless you feel like you need a plan B for the CAD software. So we're going to jump into chapter 9. And you'll kind of notice the stuff, is pretty familiar, but I do have an extra folder here. So this is a chapter 9 tutorial files. We'll talk about that when we get there. But we're going to first start with looking at the PowerPoint presentation here that I have in this folder. This is a PDF format of chapter 9. So I'm going to pull that up first, and we're going to talk about some basics here in terms of assembly drawings, and then specifically looking at in terms of Creo. So So if you want to open up to page 287, which is the start of this chapter, we're going to be looking at kind of, section by section-ish of what we see here. So first of all, an assembly drawing is going to show how parts are put together to accomplish a function, if you would. So an assembly drawing here is going to show multiple parts put together. It's going to list what they are. We're going to have balloons so we know in relationship to each other where they're at, what their part number would be, and then how many of them we're going to need to use that. We're actually going to be putting the swinging link together as our first tutorial in our chapter here, chapter 9. Now, a sub-assembly is going to be looking at maybe a small chunk of a bigger part. So maybe we can put together a couple of small assemblies, so sub-assemblies, before they actually get put into their final form to ease manufacture or assembly of the full amount. So sometimes when we have really large machines, we break it into sub-assemblies before it actually comes together to make the full machine assembly. So sub-assemblies are going to show then a couple of parts or a section of a machine for which then it's going to go into a larger portion. Now, assembly drawings can be sectioned so that we can see internal features, okay? This particular chapter 9, we don't go quite that far. We're just looking at, okay, let's bring all those parts in. Let's make sure we know how to get them oriented where they need to be so that we can have parts that are working together. But then this is going to go that step further when we start putting them on borders and we start ballooning and we start looking at, okay, can we see all the parts that we need to? And if we can't, we may need to make sections so that we can see and balloon parts that would be internal to it. Okay. Now, assembly drawings, solid round parts here. So for instance, if I have a shaft, okay, that is going through an assembly, and let's say I section through it, we do not use section lines on long extended cylindrical parts. And also things like screws, nuts, pins, keys, ball bearings, roller bearings, and gears as well. So these are things that are kind of part of that dimensioning standard, if you would. So we'll continue to practice these things as we go along. And then typically hidden lines are omitted, okay, since they tend to confuse rather than clarify. In terms of, we go back over here, if we start putting in all the hidden lines because we have now multiple parts that are together, it would actually start to look kind of like a mess, okay? So we normally will take out all of the hidden lines in an assembly view, and then if it seems like maybe we need to put a couple back in, we do it on an individual basis if it's going to add clarity to the drawing. But if it doesn't add anything, we leave them off. So the default is really to leave them off, but there's not a standard that says no hidden lines on assemblies. We are only going to add them if they add value and clarity to the actual assembly itself. So that's why it says typically omitted, okay? Now, different types of assembly views, keep in mind that the purpose of assembly drawing is to show how parts fit together, how they fit together, and to suggest how that device is going to actually function, okay? Its purpose is not to describe the individual parts. So there are no dimensions for individual parts on an assembly drawing. That's your detail drawing. That was what we looked at in our first Creo class. Now we're going to start saying, okay, we want this, and this part to come together. How are they oriented to one another, okay? And that is the purpose of an assembly drawing, not to say, oh, that hole there needs to be a 1/2 inch, okay? And what is the tolerance on that? That's detail drawing stuff, okay? That's individual part stuff. Dimensions are not given on an assembly drawing unless it is needed at assembly 2, for instance. If there's some sort of a dimension that something needs to be adjusted to, that can be on an assembly after all the parts come together. That's something that can be on assembly, but we are not dimensioning other parts, and what they look like on that assembly drawing. Sometimes we may do, once we put all the parts together, we may want to know what is the overall length or height or width of that particular assembly. And that might be something that you add as a reference to an assembly drawing, okay? Parts are going to be identified on an assembly line, on an assembly using balloons, okay? So they say, circles that are containing the numbers. We call those balloons, okay? And they're going to point to the specific parts and identified then in what we call the bill of material. Bill of material, balloons, section views are going to come after chapter 9. That's going to actually be chapter 10 stuff when we actually start creating the drawings, putting the bills of material on and kind of preparing our assembly drawings to be used out, on the shop floor. Okay. Right now, chapter 9 is how do I get all these parts together? How am I going to constrain them to be sure that they are going to meet the design intent in the end? Okay. Now here too, it talks about when we arrange those balloons, there are good ways of doing it, better ways of doing it than not so great ways. So it says here the circled numbers should be arranged in a neat clockwise or counterclockwise fashion. Sometimes students will actually put them all in line, for instance, or put them in kind of an arrangement around the outside. And that is really nice because if they're scattered all over, then they're harder to see. Okay, it's also nice if possible, and it's not always possible, but as you kind of go around, maybe your numbers go 1, 2, 3, 4, 5, in order, numeric order, as opposed to kind of being all over the place. It helps the person who is trying to assemble it to kind of, easily see where parts are coming together. Okay. Leader lines should never cross each other. Okay, so if it's a leader line coming from a balloon pointing to a part, no crossing of those. That's not okay. They should be, when appropriate, as parallel to each other as possible. The bill of materials must be provided on an assembly drawing, as we talked about. It's not going to be the focus here of chapter 9, but it's going to be that listing of all the individual parts that we would have pulled in that are going to now be identified through balloons and then quantified on that bill of material. The bill of material always needs to have that balloon number, the part number that we actually have on there, how many there's going to be, and then a description. Sometimes we put material on there. I'm not a proponent of that because if you end up switching material, now you've got another place that it has to be identified. So they have material specified, but I don't know about that. We'll talk about the required. We'll talk about the requirements. Bills of material can actually also be on a separate sheet of paper, but we're going to be creating ours so that they're right on the assembly drawing itself. So assembly drawings, Creo assemblies, the assembly will reflect any changes made to the assembled parts. So for instance, if any changes are done to the individual parts, they will be reflected in the assembly automatically. That's the parametric part of Creo parametric, meaning that wherever I make a change, that change is going to cascade over into all of the areas where that part is used. Okay. Bidirectional associativity is also one of the functions of Creo parametric, and so we can make changes in the actual assembly, and they will cross over back to the detail drawings. Okay, so that is one of the huge benefits of parametric software, is that ability. The best way to assemble a machine or structure is to do it in the same way it's going to be assembled in like the real world. So you got to think about, okay, what is the first part I'm going to grab so that I can actually get things going? So there's usually going to be something like a base piece, all right? And that is going to be then the first number that we assign on our bill of materials, so that we kind of create the bill of material in a way that is going to be the order for which we're going to assemble it. And that's what we do when we pull parts in. So understanding how parts are made, how they're going to be assembled, thinking about that assembly process is really important as we go through this, because Creo is going to mimic that very same thing. Sub-assemblies or groups of parts are going to be treated the same way as individual parts in a Creo assembly. So if we bring a sub-assembly in, it kind of becomes its own like part, okay? And then we apply the constraints as appropriate for the positioning that. So parts may be colored in an assembly to help distinguish between them. And I'm actually going to kind of demo that in our particular assembly today. So So you'll see me do that so that we can see that differentiation of the different parts. But all parts must be in, excuse me, the same working directory, So we can't have parts off in different directories because it's always looking to that working directory. So when we start any session, just like it was for the parts generation, for assemblies as well, we're going to set that working drawing or that working directory right away. Okay. Creo assemblies are going to have placement of constraints that are going to create what we call these parent-child relationships. So kind of starting with that base piece, that first component has to be fixed in the assembly. Even if it's moving in its final function, that first one has to be fixed. And we're going to see how we do that in each one of the assembly tutorials that we do here through our lectures. Then a new component is going to be placed in and oriented to that base position or that fixed one. And it becomes, if you would, the child of that assembly now, okay? So the first component must be fixed, and I'll show you exactly how we do that. When it's fixed and it's just like in space, it's going to be fully constrained, and we just hit our green check mark, and then we continue on after we place that very first item. Then once we decide, oh, I want to pull in another element here on the end of the shaft that would have been fixed, we're now going to put a small gear, okay? Now, through that, there's a number of different ways that we can accomplish it. Now, there's an automatic, there's distance, there's all these different types of constraints. And we'll be talking about a number of them and experiencing, but the most popular one is coincident, okay? And we can coincident an axis, we can do planes, we can do surfaces, we can do datum axis, datum planes. So it's very, very versatile. So we'll be using coincident quite a bit. Distance is another one where if we need to basically have the parts coincident, but we want them to be offset by a little bit of a distance, we're going to be seeing how to use that as well. But once a part comes in and it's ready to be oriented to the assembly, you'll notice that we have like these like circles going around here. And we have then the lines as well. So they're red, blue, and green. And these represent 6 degrees of freedom that any part has when it's brought into an assembly. And we need to nail those down. So we need to figure out, okay, rotationally, what orientation should this be in to the other part that we're going to be mating it with or constraining it to? What surfaces may need to come together? What axes need to be lined up with one another, okay? And these little arrows are going to help us get it kind of close to where it needs to be, and then we finish it off with the constraints that we're going to be applying. Now, we can also accomplish some of this through identifying some ways canned ways, if you would, of putting these parts together. One of them that we're going to experience here is going to be a pin, okay? A pin is going to have the ability for something to rotate about an axis. So here we want to be sure that this gear, okay, is going to be able to rotate relative to, all right, the shaft here, for instance. We're going to have our link on our assembly. We want it to actually rotate when it's on that pin. We don't want it to be fixed. It actually has to have the ability to rotate about that, so we can test that once we have everything assembled. So again, the most popular constraint that we have available to us is going to be coincident, and we can do that in terms of an axis, a plane, and or surfaces. Now, you can over-constrain things, but what we want to do is we want to stick to what is the final function, or how would we set that up if we were trying to align it or put it in position. And that's what we're going to default to as the starting point for each one of the parts that we're going to be putting in place. PTC or Creo recommends a limit of 10 constraints between 2 parts, but you can really have as many as 50 that it's said in the book, okay? So anything, and you'll get a message when you are fully constrained, okay? When you are fully constrained, you'll maybe put 1 constraint on and it's gonna be like, we need a little bit more. We don't have our green check mark yet. And as soon as you maybe put the 2nd or the 3rd constraint on, now you are ready to, depending on where it's at, now you're ready to actually, do the check mark and say, yep, we're good to go. Parts in an assembly can also be patterns, just like we did features on an actual part. So we have, one of our tutorials is going to be creating a ball bearing. So the balls that are in there are their own individual part, if you would, inside of the inner race, the groove that's on the inside there, but we're going to position them evenly around a center. Okay, so we're going to use patterning similar to what we did when we were doing the part patterning, but it's going to be in an assembly form. Now, here are sub-assemblies and assemblies. So through the tutorials that we're going to be creating in Chapter 9, we're going to be creating this sub-assembly 1, if you would, and this is, I think, called the take-up frame assembly. We're going to be creating this ball bearing, okay? And that ball bearing is then going to fit inside of the take-up piece itself. And then these are going to come together in the final assembly. So you can see the frame here, the take-up piece with the ball bearing, and then we're going to have this, screw rod that's going to go back and forth to do the adjusting that we need. Okay, so this is going to be a full assembly that we create. We call it the complete take-up assembly. Is going to be something that we work through. Now, I have the wrong name here for this. This is not going to be called AV tutorials. These are going to be called Chapter 9 tutorials. I was playing around a little bit with what I was going to call these learning plans, and I felt like in our last class when I had learning plans and then learning plans were made up of chapters, the chapter numbers didn't go along with the learning plan. So sometimes I was confused at which chapter we were in the book on which learning plan. So I ixnayed the learning plan. So this was kind of in my transition phase. So these are actually going to be Chapter 9 tutorials. There are 5 of them. There's going to be the swing link assembly, the take-up frame assembly, a ball bearing, a take-up piece assembly, and then the completed assembly like we saw over here. So there's going to be one extra to what you see up here. All right, so there's going to be 1, 2, 3, 4 assemblies plus the initial swinging link that we're going to be doing that actually looks like, we actually saw it up here. We're going to be doing this one right here. Now, oh boy, it was all the way back at the beginning. It's going to be this one right here. All right, so that really takes care of kind of the overview of, but I encourage you to actually read through. There's the first pages here of the text through page, if you would, 292, only because it gives us a really nice overview of the different constraints that are out there that we may not be experiencing all of them in this chapter, but you know that they're out there and will probably be coming up a little bit later in other assemblies that we do. Okay, so any questions right now kind of on the parts, if you would, or the first part of Chapter 9 here? Okay, all right, I'm going to scooch over here. We're going to stop on my PowerPoint at that point. And what I want to do is kind of go back a level and show you the information that we have here. So you'll notice that underneath our PowerPoint now, we do have Chapter 9 tutorial files. And what I've done is over here, if you click on that particular folder, you're going to find the each one of the files for each one of the tutorials that we're going to do. So the swinging link assembly parts are going to be these 4 parts that we see here. Now, to access these parts, all you need to do is to download each one of these, okay? So my hope is that you can download, okay? Download just by clicking them. Now, what I want you to do is to watch. Down here at the bottom of my screen, you'll notice that I have a parentheses 1, and the previous one did a parentheses 2. And the reason for that is because in my download directory, I already had these saved. So when it sees another one, it doesn't save over the top of it. It just makes another copy of it, but puts the parentheses in there. Now, what you need to do is you need to get all 4 of these, okay, into the same working directory. And if you ended up, maybe you didn't download it the first time, they were fine, but let's say you kind of backed up and you're like, oh, I want to start over, I'm going to download them again. and you end up with these parentheses 1s or 2s in back of the .prt, you need to rename those and get rid of those parentheses, because otherwise it's not going to recognize it as a Creo file. Okay, so if I go into my download directory here, downloads, and I look at these files, notice right here it has a parentheses 1 in back of it. All I need to do is click on that, hit a right click, and say, I want to rename that. Okay, I want to rename that, and I'm going to go to the very end here, and I'm going to just get rid of anything that's in back of the .prt so that it becomes a .prt. And I'm going to hit OK. Oops. All right, that's there. I want the same, there's another file is with the same name in this location. Do you want to rename? Yes. No, I don't want to do, wait, why am I not doing that correctly? Oh, you know where I can do it here. I can get rid of that. I'm going to do enter, and there's already, I know why. I actually need to put this in my directory first. So down here in my, wherever your working directory is, I'm going to put it in Creo 1 on my desktop. I'm going to slide this over to Creo 1. I'm going to put it in there. I'm going to put each one of these, even if it's got the extra in there. I'm going to go over to my Creo 1, and now anywhere I see those guys, this is where I'm going to be able to change it because the extra copy isn't there. I'm going to rename it. I'm just going to get rid of this right here. I'm going to click or enter outside, and it stays because there's not another one in this new directory. So again, if you download it and it does the parentheses 1, switch it over to the directory you want it to go in, the working directory. Okay, just push them right over in there. And then what you're going to do is you are going to get rid of that parentheses 1 by clicking on it, renaming it, and then just grabbing, going into the end of it, and then hitting enter, and it gets rid of that parentheses 1 at the end. Okay, so do it in the working directory when you slide it over, because otherwise, if it's in the one where the copy, the original copy is, you're going to get that error that I just had. Okay, so I'm out of there. So now I have my files in my working directory, and I want to do that for each one of these. Now, I did have one of our students say that when they downloaded these and they pulled it up in their version, now their version would be the educational version, which my version is as well, okay? If you're having difficulties, please let me know right away, because I'm not, and I don't know exactly why I'm not, because to me, I'm using the educational version as well, and it's saying something about commercial parts being pulled up in an educational version. So if you have that issue, let me know right away, because we're going to have to kind of figure something out with those. So, keep me posted on that. Keep me posted on that. But in the meantime, for the person that is having difficulties, I will be working on it, I promise you. So this is going to be my swinging link assembly parts, okay? So I have those in place. Now, what I'm going to do is I am going to, when I have those into the working directory that I'm expecting using, I'm going to go into Creo 7, the parametric, like I normally do. We may only get through our first tutorial today, but that's okay. All right, as I'm looking at the time here. All right, so I want to start working. I'm going to get rid of these two guys right here. And then what I'm going to do is I'm going to set my working directory first. Now, I'm going to set my working directory to my H drive Creo, and I've been calling it Creo 1. I'm just going to leave it. I'm just going to leave it as Creo 1. I know we're in Creo 2, but I'm just going to leave it because I've been using the working directory as that. I should really rename it to just Creo working directory so it's common. Now, once I have that working directory set, and you still do need to do that, even though we're going to be pulling parts in, that working directory has to be set first. And now I'm going to start new assembly. I have to have design up here, and then I'm going to put in what I want to call that assembly. In the book that starts on, this tutorial starts on page 293, all right? 293. And where I'm actually starting is going to be actually on page 298, step 1. They have you download that, that retaining ring at the very beginning there in the first 21 steps, all right? I'm not having you do that. I already have it downloaded for you, so you don't have to worry about it. So we're actually starting on page 298. So I'm just going to briefly go underneath here. Let me see. Oopsie. Cancel that. There we go. So where we are starting is not at the very beginning, but we're starting on page 298, step number 1 here. Okay, step number 1, once I get everything pulled up. We are just not downloading that part. Okay, we're just not downloading that part. So let me start over. New, I want an assembly. Design is going to be clicked. And my file name, we're going to call this, and I always do all caps, swinging link. Okay, and I think I have like a couple versions because I've been playing around with this. I'm going to call it, mine is going to have a 3 in back of it because I need it to be new. Then okay. All right. Now, what we're going to do is we're going to start by pulling in our first part and setting it as the fixed initial part that's in here. Now, remember, even if it's moving in its final form, it's like it's starting our assembly process. It has to be fixed. So I'm going to go up and I'm going to, underneath this model tab, we're going to hit the assembly icon or assemble icon. And then I'm going to pick the part. My part is called base.prt, already created for us. And then we're going to hit open. Okay, and now it goes right into component placement. All right, you see that here. And component placement, there's not much to do here because this is our first one. And it says user defined, but I'm going to go, I'm actually not that one. Wait, not that one. It's going to be under automatic here. I need it to go to fix. Okay, it's going to be on this second one. So I'm going to do fix. And all I do is, I actually do nothing. I can either hit the green check mark or I can do the middle mouse button to just say, okay, we're fixing it. That's the first one. And it kind of identifies it as our first one. All right. Now what I'm going to do is I'm going to pull in my second part. Okay, I'm going to pull in my second part. So I'm going to hit the assemble again. This one is my clevis, okay, which is right there. All right. Now again, if you pull it in and it's like the second time it was brought in, if it has that parentheses 1 in back of PRT, it will not populate in here because it's not one of these file formats. I made that mistake and it took me, I'm like, wait a second, it's here, it's not here. And it had the parentheses 1 in back of it. So when you transfer them over to your working directory, make sure that if it was a duplicate and it created that part, parentheses 1, 2, 3, whatever it might be, that it's not in here. You want to rename those so that they populate because it's only going to see .prt, not .prt parentheses 1, parentheses 2. And I'm going to hit and open. Okay. Now, what has happened here is you'll notice that my part is purple when it comes in, and I've got like all these little things on the back side of it. These are my degrees of freedom that I can move this part. So I've got kind of this global one that goes around this axis that it can rotate. Okay, that's 1 degree of freedom. I've got another one that goes around this degree, this axis, okay, that way. And then my third one is oopsie, shoots. Lost it. I hit the middle mouse button. I'm so mad at myself. So let me bring that clevis pin back in. Okay, so I can rotate this way. Okay, I can rotate this way. All right, and I just left mouse button and I'm dragging, and then I'm going to release. And then I can rotate, which one was it? The blue one, this way. Okay, so that's 3 degrees of freedom. And then I can translate vertically, horizontally, and all I'm doing is I'm clicking on each one of those arrows, and this is going to go horizontally, and this one's going to go in and out. Okay, so kind of practice that by picking with your left mouse button and dragging, whether it's rotationally, if it's translationally, okay, and then releasing when you get it to where you want it to be. And this is how we kind of place it-ish, okay? Now, again, if you end up doing what I did, all you got to do is just, you can cancel out of this, and you're like, oh, crap, I'm kind of confused here. I don't want it where it's at. And I just want to, start over. All you can do, you can just hit cancel and then re-pull it back in. That's all you got to do. All right, so this is here right now. Now, I don't have anything placed. So you'll notice here that, we don't really have anything. And the status says no constraints. It's not going to let me really do anything. So I want to place it. And I want this to be a coincident placement, okay, coincident. And I'm going to rotate this around a little bit. There's a couple things I'm going to do. So first of all, I want the outside of this pin to be coincident with the inside of the bore on my base. All right, so I put those two coincident, and all I did was I selected the outside surface of that pin and the inside surface of my bore. Okay, and it put those in line with one another. All right. Now the other thing I need to do is position this so that it's inside of here, right, where it's supposed to be. So the other surface that I want to be coincident, I'm going to add a constraint. So I need to add a new constraint. So I've already got one that is coincident. I'm adding my new one. Now it already goes back to automatic. You can try automatic. Sometimes it's kind of smart about that, but sometimes it's not. All right. So I'm going to try automatic. Click there at that surface, and then this surface right here. And it wants to do distance. So it wants to set up for me, like, how far apart should these be? You could put a distance of 0 in there, and that would make it coincident. Or we can do this. We can say, instead of that, let's do coincident, and it moves it into the position. Now, sometimes automatic works really well, and sometimes it doesn't. So it's not a bad thing to like start with automatic, because it could be really helpful, but sometimes it's not as intuitive as you would think. Okay, let me kind of get back over here. So that is there. Now you'll notice up here it says status is fully constrained. So I'm on the same axis as the bore, and I'm pushed into position. Okay, so fully constrained here. I can hit the OK or my middle mouse button. All right. Now what's happened here is you'll notice that I'm going to kind of position this like this. What's happened here is that everything is all the same color, and what it looks like to me is that it's all one piece, right? So we can actually change the color as we go along, and so you're going to see me do that so I can distinguish between the different parts. So I could change the base if I wanted to by just selecting it, and then up here where it says appearances, I can change, you know, the color if I wanted to. So maybe I want to make this a little bit darker. Okay, you'll notice that it made this now a little bit darker shade than what the pin was. Now I'm going to go on my clevis, and I'm going to do the same thing. I'm going to highlight it. I'm going to go up to appearances, arrow down, and I'm going to actually do it in yellow. Okay, so then I can really see that difference. So play around with the colors and stuff there if you want to. You don't have to. It's not part of the assignment, but just know that you can do that so you can see that differentiating qualities of it. Okay, so these are my first two. I can do a save right now if I wanted to, and it'll save it in that working directory under the file name that I gave it. But I'm going to keep working, all right? I'm going to keep working. I'm going to tempt fate, and I'm going to, you know, hope for the best. But I do encourage you to save. Again, save every time where you're like, I don't want to redo what I just did. Save, okay? Now, I'm going to be adding in my link in here. So the next thing I'm going to do, I'm going to go back to Assemble. I'm going to find my link.prt, all right? And I'm going to open that up. Okay, so here it is, and it puts it in this position. Now again, I have that ability to kind of get it close to where it's at, because sometimes it's not going to be on the right plane or in the right position. So I may want to, you know, translate it in and out here so I can see a difference, or up and down, or I might want to reposition it. Look at it, it goes over this way. All right, it doesn't have to be perfect, but sometimes we want to just make sure that it's, you know, close-ish to where I want things to be. And it's kind of, I don't know, it's kind of fun to play around with it. All right, so now I've got these two guys in position here. All right, now as I look here, I'm now ready to place it. I have no constraints in play right now. That's what it says here. I still could hit OK and just have it floating out there, but this is an assembly. I gotta put it, you know, with the other parts over here. So I'm going to do my placement. And there is an automatic option here. I can do that. So I always like to say, try it, see what you can do. So I'm going to do the outside surface of that pin and the inside surface of my link. Okay, so it lined those two up. It lined those two up. So if I look down here, notice that they're lined up. All right. Now what I want to do is another constraint that they want is they want to pull this in, but they want there to be a gap between the offset surface right here and the offset surface in here. All right, now I believe if I go on to this, I should be able to edit definition and get back in there. Yes, okay, so if you do end up with that, you can go back in like this. Now, placement wise, it's going to remember that set that I just took, you know, originally. So now I'm going to do the next one here. I'm going to say, okay, I want this to be, now this is going to be distance this time. Now, of course, distance is, oh, no, I have to apply a new constraint first. Now I'm going to select distance. Where is it? Right there, okay? And what I'm going to do is I'm going to select the surface on my base right here, and I'm going to then have the ability to move this around, and I'm going to select that surface right there. Now, currently, my distance right now is 1.69, so it's identified there. I want it to be, the book tells me, 0.01. Enter. Now, if I zoom in here, zoom, 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 notice that, yeah, it's not right on top of it. There's this little bit of a distance of 0.01 right there for a little bit of play between those two surfaces, okay? All right. So that's there. My link is in place. Oh, you know what I didn't do? I didn't do this. Now, I wonder if I can go back and change this right now. Let me go up here. Let me go to user defined. It's a rigid. Dang it. All right. This just means, you know what? I'm going to cancel this. I'm going to pull this back in. Do you really want to cancel? Yeah, I do, because I didn't do one thing. What I didn't do, I'm going to be on my link here, and I'm going to edit definition. I'm going to see if I can do it here. I don't want to be a user defined. I want to be a pin, because I need the ability for this to actually rotate about, okay? So on this link, I need that ability. And now what happens is it says, okay, I want this surface to be coincident to this surface. All right, so it lines that up. That one's there. And then what I need is I need to add an axis alignment. This one. I need to do the translational now. Translational is going to be how far back and forth do I want this, okay? And I want to have not a coincident, there we go. And then I need the new set, I'm pretty sure I'm going to do between here and here. I think I have to start over. I'm sorry. I'm going to X out. I tried to do something I wasn't sure of. Do you really want to cancel? Yes. Let's pull the pin back in, or that link back in completely fresh. I'm going to delete it out of here. Yes, I want to get rid of it. And let's reassemble, brand new link, pull it back in. I'm sorry. Thought I could maybe edit the definition, but it wasn't as clean as I was hoping. So right now, before I do anything, under user defined, I want this to be a pin. Okay, I want that to be a pin because, again, I need it to rotate about that center, not be rigid and fixed. Otherwise, the assumption is rigid. So when I do that, I'm going to go to placement, and I need my axis to align. So I'm going to put my axis right here, this guy right there, in alignment with this axis. Notice when I get close to it, it actually is going to highlight. Now what I'm going to do is I am going to do not a coincident translation, but I need that distance in there. So it automatically has it here because I'm in pin, and I'm going to, I could select it where I was, but I'm going to do this surface, I'm going to rotate that way, this surface. And now it has 0.00, but I actually want this to be 0.01 and then enter, and notice it pushed it back just that little bit. That's the right way to do it as a pin. Now, why do we want it as a pin like that? And I'm going to hit OK here, all right? I'll tell you why we want to do it. Number one, I'm going to select this. I'm going to change my appearance. I'm going to make it red to start off with. But now, to know if that pin worked or not is if I can hit this drag component, all right? And over here, I'm going to say I want to select one item. So I'm going to select one item. I'm going to select the link. And now when I'm over here, I can go back and forth. Now, I am not clicking anything. I'm not holding any mouse button, but now it offers this ability to rotate. If I would try to do that with this pin inside of my base, I can't do that. Now, it wouldn't be real apparent because it's a round part and there's not like an extension off of it, but it's in there rigid. That pin is not moving anywhere, but my link does have this ability to move relative to that rotation. So when you need something to move like that, in its final form, identify that as a pin because then it'll line up the axes and then you can get your translational, in this case, from that offset distance. Okay, we're not quite done yet. We have one more piece to put in that always gives me a little bit of trouble, so I'm hoping it's going to cooperate this time. So again, this would be a great place to save. I might as well. So File, Save, and it's going to be, you know, as that default in my working directory, and I can hit, yep, okay. It's going to say that it didn't regenerate and that we didn't regenerate the model, but we'll do that at the very end. Now I'm going to assemble one last piece in here, and that is going to be my SD16799. This is my retaining ring clip, okay? So I'm going to open this, and it's gonna have it over on the end here. So the first thing I'm going to do is I'm going to grab my blue arrow and I'm going to pull it forward, and I'm going to grab, even though over here this arrow shows going to the right, I'm going to click it, but it can come back to the left here. All right. Now I'm going to rotate it around so that it gets in sort of the right plane, and then I'm going to rotate it so it goes this way. So it matches the orientation in the figure on page 302 at the top. Okay, so when I look at it, it's sitting something like this. So my open part is to the right here. All right. Now here, what I need to do is when I place this, I need to actually set this to place manually. Okay, if you try to do it automatically, it's going to not do what it's supposed to. So place manually, and it's going to be user defined, and I'm going to go into placement here. All right, and what I'm going to do is, even though I'm going to do, it's going to be coincident, and coincidences, when in doubt, start there. I'm going to take the diameter on the inside of my clip. So this diameter right here, this surface, click here. And I am going to put it in line with, or coincident with, right where it's going to seat on that surface right here. Okay. So now what it's done is it's now pushed it into its orientation this way. And then lastly, I need to add one more constraint, a new constraint, and this one's going to be coincident as well. So I'm going to set that up right away. And I'm going to put it on one side or the other. So I'm going to click on this surface right here. And then I'm going to zoom back out, and I'm going to rotate this around, and I'm going to put it on this surface right here. And now it moves it into my position. So let me zoom out here. And now I have everything in place. Look at that. Okay. Now, as soon as that's all set and it looks good, I can hit OK here. All right. And now I can see that I have everything. Now, how come it went the other way with that? I'm not sure. And really, the orientation of this is not important, like where that open spot is on the retaining ring, because it's really on the groove. I'm not sure why it switched it around. And I'm going to change the appearance. I'm going to make that blue. Okay, so now you can see all my separate pieces here go into a standard orientation, kind of move it around a little bit. And then we'll do that drag one more time. We're going to drag it. I want to do my link. And notice that I can still rotate that back and forth. So good. Okay, so that is your first tutorial and the first part of the assignment that you have. Let's look at your assignment. And I'm going to minimize this right here. And we're going to go in. And again, download these all into the same working directory so that you can work with those parts. Let me know if you have any issues at all. Okay. And then we're going to go back to our learning plan, chapter 9, and we're going to go down to the homework, okay? So our homework assignment here are the chapter 9 tutorials, and they're these 5. So the first one that we just went through is the swinging link assembly. Now, on page 303, let's see if I still have that up. I do not want you to do the exploded views, okay? This is a huge pain in the tuchus, okay? So I know exploded views are nice, and I think they are way easier in SolidWorks, but I don't want us to worry about assembly about these exploded views right now. We'll work on those a little bit later. It's kind of an added thing here, and it is not easy to navigate. It's a lot of playing around, which I don't want to be the focus at the moment. So stop on the bottom of page 302, and this is going to be where we end this tutorial. We're going to skip the exploded stuff for this one, and then our second tutorial is going to be putting together this take-up frame right here. And that's what I'm going to demonstrate tomorrow, okay, among the other ones that are there as well. We'll probably get through at least 2 tomorrow, and then maybe a third one. We'll kind of see. But I want to get through each one of these 5 tutorials that you have assigned for your homework, because these are going to be due next week, Friday. So you'll have some time in here to work on those and have some good resources for it. Okay, so that's going to be as far as I want to go today. Oh, let me get out of here. Let me go back over here. So according to our course calendar, we started chapter 9 today, which we actually did. We went through and we looked at the syllabus, the course expectations. Tomorrow we're going to continue on in chapter 9 here, doing some more assembly stuff of that take up, and then I'll let you guys continue to work. As the week goes by, we're gonna be continuing on to chapter 10. So I'll start populating in that, so that if you get done with the chapter 9 stuff early and you want to work, especially when you have your break, I'll have that out there available for you to start on independently if you so choose. Okay, so that's all that I have for today. I'm going to stop sharing. Does anybody have any questions? Gisela, you're my final customer. Do you have anything before I let you go?
No questions. I just looked up that maybe you could save the files as step files.
Okay.
And then I could import them in, but I'm not sure if that'll work.
Well, it's one way to do it, but let me find out, because these, like I said, these files, for the person who's having the issue, these files are from an educational resource that we bought the books from, and then now we should be able to use them right in this educational format. So let me see if anybody else has that issue, and then what we can do for converting those files. Are they part files just like you see? Like, it doesn't change?
Yes.
It all looks the same. Okay.
They're just part files, yeah.
All right. We got to get you up and running. So we'll figure that out. Okay. And as soon as I do find out, I will let everybody know. Thank you. All right. Have a great day.